All right, we're looking at recursive equations first. In a recursive equation, we have our output that we're looking for. So this is the current term. And then that equals the previous term. F of n minus 1 is the previous term. And then our action. So what happens to it? We're also choosing an input. So what's our input? And we can select the input, and then we have to find out what that output is. It's a place to begin, so we can choose that ourselves. Okay, so let's look at an example. Our first job is to figure out what is the action. So from 7 to 10, from 10 to 13, 13 to 16, and 16 to 19, we can see that it's growing by 3. So this is an arithmetic sequence. We know it's arithmetic because it's repeated addition. So our recursive equation is going to be the current term we're looking for equals the previous term, or f of n minus 1, and then our action is plus 3. Now our start value, you can choose which one you would like. I prefer to choose 0 if it's an option. So our input is 0, so f of 0 equals, and the number output is 7. So f of 0 equals 7, and this is my start value, where this is the action. And in arithmetic, we can call that the common difference. All right, in our other equation, when we look at it, 2 to 6, 6 to 18, 18 to 54, and 54 to 162 clearly does not have a common difference, but a common ratio. And in this case, we're multiplying by 3. Now, sometimes it can be hard to find out what the common ratio is, but if you were to take 162 and divide it by 54, you would get 3. 54 divided by 18, 3. 18 divided by 6, 3. 6 divided by 2, 3. So you can check and find out what the common ratio is using that method. Okay, so this is a geometric sequence. And our recursive equation is going to be similar to that we just did, because f of n equals f of n minus 1. That part doesn't change. But in this case, our action is to multiply by 3. We do need to choose a start value, and I'm going to choose 1, 2. So in this case, my start value is f of 1 equals 2. So my input was 1, and my output was 2. So my start value is 2. And this is my action, which is a common ratio of times 3. So these are the recursive equations. We're going to go down now and look at arithmetic equations. We're using the same information, except this time we're doing an explicit equation. So the first thing we have is our current term And then we're going to have our start value. So in this case, our start value, and then our action. And then this part's really important. This part is how does it relate to our n value? Okay, so how does it relate to our n value? If it is n, then we don't have to take anything away. But if it's different from n, so say relates to start value. All right, so let's look at this. We know what the action is, and we know what the start value is. So our f of n equals our start value, which in this case we said was 0, 7. So this is what we're using. So our start value, 7. This is arithmetic, which means I'm adding. And this time we're adding 3. So I'm actually going to change that to be green, because that's what we did up top. So plus 3. And then the question is here is n minus what? Well, because our n value was, our start value was 0, 7, we don't have to minus anything, so we're just going to multiply it by n. Okay. So the same thing over here. This is the current term I'm looking for, or sorry, the output. It's not current term, that's recursive. Our output. Okay, and this is going to be our start value. And this is going to be multiplied by, in this case, our action, which is 3. And then this is how it relates to our start value, and we'll show what that means. Okay, so f of n equals my start value, which was 1, 2. So my start value was 2. And this is geometric, so I'm multiplying that by the action. In this case, our action was multiplying by 3. And then this repeated multiplication is written as an exponent. So n, but do you see how our start input was 1? We need that to be 0. So n minus 1 will get us to 0. If we look at these two, this minus 1 and this plus 1, when combined, equals 0, and that's what we need n to be. So that will take us from our start value of 1 to our start value of 0. So you can look at the difference between this side, where we had a start value of 0, and we were just left with n, and this side, where we had a start value of 1, and therefore had to minus 1 to get to 0. And that's it.